Hello, my name is Marcel de Jong. I'm Technical Team Lead in North America for M&E, and I'll be going through another Arnold workflow exercise. The following topics is what I'll cover in this exercise. Vegetation is listed because I found a number of pine trees that I'm using from the older Autodesk Seek library. They have alpha textures associated with them down to the individual pine needles, and I'll show you what that looks like in the viewport. We'll talk a little bit about the color jitter node, which is a new node in Arnold 5, allowing you to control color randomness across faces or objects. We'll also go through a workflow where we actually take the trees and then export them as .ass files, which are the Arnold scene source files, and then bring them back into a stand-in, which is a bounding box volume by default that you can then go ahead and replicate thousands of times across the surface. So that replication we're going to do through MASH. So we use MASH to replicate stand-ins in the scene. And then we'll apply an ID node to identify and to select from the three trees I start with to randomly place the three across a surface. And then we'll use a random node to randomize things like rotation, scale, and translation. Last thing we'll do is we'll apply a physical sky texture, which is essentially a sky dome light with a physical sky texture associated with it, to control the illumination and the shadow casting. So with that, let's look at a couple of pictures here. So this is the first one. It's about 600 million polys in the scene that are being rendered using stand-ins with a little bit of variation in scale, translation, rotation. Another example where you can kind of see the separation between the trees and the shadow casting from tree to tree through the actual alpha textures. It's a little far away for that, but it's a top view if you were to fly over a forest like this, what you would see. A close-up of the shadow casting, which is actually casting shadows through the alphas. So each individual pine needle actually has a shadow representation somewhere. And then the last one, which is the one that I'll actually create here as part of the exercise. So we'll have a surface that we place these stand-ins on and then randomize them across that surface. So with that, let's jump into the software and look at what we have. These are the three trees that I'll use to do this, and you can see that all the textures for the pine needles are sitting on cards. Usually when you're dealing with something like this, you not only have the alpha problem, but you'll also have a sorting problem. And so we introduced in one of the fairly recent releases, we introduced the alpha cut transparency mode. So under hardware render settings, viewport 2.0 settings, you can set this to alpha cut, and you can see that it now starts to clip correctly, and it also sorts the needles correctly, so you get a proper sorting from front to back that doesn't really interfere with itself. So with that, what I'd like to do is throw in a light real quick. So we'll create a light, and if I select physical sky, it actually creates a sky dome with a physical sky texture associated with it. So that dome sits around my scene if I want it to kind of not be there so that I don't accidentally pick it, or things that are black don't really disappear against the backdrop. You can go to viewport and set the sky radius to 0. The light will still function exactly the way it did before. So with that, let's jump into the hypershade window real quick and look at the textures that we have associated with these trees. And in this case, we get these three right here. These are the color textures that I'm going to be manipulating or randomizing somewhat. But before I do, I want to go ahead and render this out so that we can actually dock the ARV, the Arnold render view, into the hypershade window. And with the two docked together, we can maximize this and use this UI to do all of the work that we need until we start rendering a forest. So let's stop this for a second. We have the three shaders, we have the three trees, and if I were to go in and actually select the geometry, you could see the red outline around the shader tells you which shader is associated with the tree that I just picked. So the one in the middle is the shader in the middle, so that's the one I want to start with. And if I select a texture, you can see that the color offset for this is that green that I see on the tree. And so what I'm going to do is I'm going to go ahead and sample that color to essentially store it so I can always go back to it. So with that, I can then map that with a color jitter node by selecting the Arnold tab there and then start punching in the name, and at some point it'll actually filter down to the actual node. And if I load that node, you can see that in this case that node has an input of white, which makes that tree, makes all the pine needles render white. We can of course go in here and apply a texture like a volume texture to it, and that too would be a good way to introduce noise. But what I want to do is just use the color jitter node. Otherwise you'd have to have more nodes feeding into that color jitter node. So let's drop down, or let's actually load the original green color that we had on the tree. So we're basically back to the original configuration in terms of color. If I then go in and maybe say, well, let's maybe lighten that up a bit, you can see how that lightens up. Or maybe go back to the original color or close to the original color. You can go to Object and you can modify a color gain or a variance in color gain. Maybe set this to like 0.1, a fairly low value, and then maybe space out your U-min and your U-max values to introduce a little bit of color variation. So you can see that in this case, if I get a little closer, we get cooler patches of pine needles and warmer patches of pine needles. And then of course if you wanted to go in, you could take the source color to which those U variations are applied and maybe shift it over more towards the warmer part of the spectrum, and you can see that now we get some browns involved as well. So that's a very simple, easy way to vary the color within your trees and the overall impression of each of these trees. So let's go ahead and pick the one on the right, and that's this shader right here. If I stop my IPR render here real quick, I'm going to go ahead and do a Control-C, Control-V. I can then select that shader, that texture that I want to apply this to, maybe drag and drop this in. And we're going to get the same result here on that tree. And if I open this up, we might want to change some of the values here, having it go to maybe something lighter. Also maybe something under Object, we can make this gain value a little bit different. We can also shift the U. And you can see that this is becoming a little more red, or maybe I want to shift it more towards the blue part of the spectrum, something like that. So you can vary this however you need to. Once you have enough variations between the trees, which later on is going to mean that when the trees start mixing, you get enough variation in the forest, which really helps create a sense of depth and distance. Alright, so with this, obviously you can create presets for this as well if you wanted to go ahead and store some presets for this particular node. The third tree, I'm going to leave it alone. I'm going to leave it exactly as the original color. And so with that, we can go ahead and tear this back off. Maybe we'll stop the render here. We can close it. We can close the Hypershade window. And what we need to do is actually export these trees as files, as .as files. So with the first one selected, let's go to Arnold, stand-in, and export. And we'll export this as tree 1, and we'll overwrite that. And then we'll go ahead and do the same thing to the second one. We'll export this as tree number 2. And then with the third one, let's go ahead and export this, but let's open the dialog here first. And one of the things that you do want to make sure is turned on is export bounding box. And so what that will do is it will export the .as file, and then it will also export a file called .assstoc, and that's a representation of the bounding box. So that when you read in the .as file, the bounding box is drawn very quickly as well. If you don't have that, export bounding box turned on when you export the .as file and then bring them back in, every time it redraws a new bounding box, it has to take a little bit of time. So if you have 10 or 20 or so, it's not that big a deal, but if you have a billion, then obviously that could be a huge problem. So make sure that's turned on. So we'll say export selection, we'll export this as tree 03. And then we're going to start bringing them back in as stand-ins. So we can go ahead and delete these now, and then say create and load the first one, create and load the second one, and the third one. And you can see that as I'm doing this, they also remember the world space positions these trees were sitting in. So let's close this, and we can expose a terrain across which we want to populate this. So let's open up the or expose the ground And with that, we can turn this into a mesh network. So with the 3 selected, I'm going to go to Mesh and open up Create Mesh Network and create an instance network, which makes it faster as well. And then with that instance network selected, we can go ahead and render this into a view so we can actually see what the trees look like. Now in this case, we get 3 trees that are exactly the same, and that's really because it's rendering ID number 1. So if I wanted to be able to randomize the IDs between the 3 trees that are loaded into this, and you can see that if you go to the weighter value, it's set to 3. If you go to distribute value, it's set to 3 points. So it automatically does that because I only had 3 objects selected. So in this case, what I want to do is I want to assign an ID node, and with that ID node, I'm going to select random and then maybe modify the random seed value. And when you select that, you can render that out, and you can see that now we get 3 different trees. Actually, in this case, 2. If you change the seed value again and re-render that again, you might get a different configuration of trees. So it all depends on what your seed value is set to. So in this case, you can see that they move over as well, right? So in this case, you can see that I get 1 of each. They all look good. The shadow casting is correct. It's accurate, and all the detail is there. So at this point, what I'd like to do is maybe go in and associate this with this surface and then increase the number of repetitions that we get for each tree. So let's make sure that we jump into the distribute node and select the mesh preset. We can select that plane and drop that in as an input mesh. And they'll show up on the mesh someplace, and I can simply increase the number of points. Let's set that to 1,000. So with that set to 1,000, you can see that each of these trees are also oriented along the normal of where it sits, depending on where it sits on the surface. So you want to turn off calculate rotation. Everything now points vertically. And we also want to go in and maybe assign a random node. So under mesh, we can go back to the weighter and open or create a random node. And with that random node, we can now introduce random values for translate, rotate, scale. So for random rotation, I might want to punch in 360. And by setting it to 360, it automatically understands that I want to randomize between 0 and 360. For position, maybe I want to randomize between 0 and 3. So I'll just give this a little bit of a value. You can see that increasing that value will increase the variation across translation Y. And then the last thing I want to do here is maybe give it a little bit of a variation, 0.3, 0.4, maybe for X and Z. And for Y, we'll make it a little bit bigger value. We'll scale a little bit more in Y. So once you're done with that, we can then go back to the distribute node and maybe multiply that times 10. So we'll have 10,000 trees. Each tree is about 170,000 polys. And if I were to turn on the resolution gate here, maybe drop this back a bit so we're fairly close to the trees in the front and fairly far away from the trees in the back, we can then render this out to see what this looks like. So you can see that as I'm doing this, I'm starting to see the variation in the forest as well as the detail of all of the needles, as well as the variation in rotation, scale, and translation. So let's stop this for a second and then maybe go back and change the illumination by selecting the light and jumping into the physical sky texture. So with that, we might want to maybe warm it up a little bit by dropping the sun in the sky to like 8, 9, 10 degrees. Let's set it to 8 degrees. And then we'll rotate it around maybe 135 degrees so it comes in from the side more or less, and then maybe increase the intensity to a value of 4 or 5. Maybe a little more intense. So with this configuration, you can see that we are starting to see cast shadows, and we're starting to see some contrast in the dark and the light areas in the forest, and as it's rendering and revealing some of the detail that we want to see. I might also want to go in and supply it with a little bit of a sky tint. Let's give it a little bit of a cool tint there, something like that. And then re-render this. You can see that the sky kind of cools off a little bit, introduces more blue. and that will also introduce more blue in the ambient areas. And then of course you can also change the sun tint as well as the sun size, and increasing the sun size will soften the shadows as well. So I'm going to let this render and kind of recap what we did. We started off with 3 trees from a library, an Autodesk library, Seek library, and they all have alpha textures associated with it, as well as just a regular color. And so we used a color jitter node to randomize the color for each of the trees, and then did that for a couple of the trees, left one alone, and then we turned each of the trees, or exported each of the trees, if you will, to a .as file to import that again into a stand-in, which will take advantage of all the optimizations in Arnold for stand-ins. It will make it render quicker. It will respect all of your shaders, textures, etc. They're called shading engines inside of the .as file, and it will render at its full resolution. So there are the performance and memory gains, as well as the interactivity that you get by sitting here and watching a forest render like this. So that's pretty much it. Thank you very much.